Analysis of the implemented project for the construction of a high-rise building between two low-rise buildings in the zone of maximum meteor influence of their foundations. The construction of a high-rise buildings in condition of dense urban development in the immediate vicinity of previously constructed buildings is always a difficult engineering task because the previously constructed building is in the zone of influence of the settlement of the new foundations, the deformation of the base and the structure of the existing one. The attached building partially rests on the compacted soil of the foundations of previously constructed buildings, which provokes uneven settlement of the intergroup of buildings located in the zone of the sedimentary final formed along the perimeter of the attached building. The purpose of our research is to assess to effectiveness of engineering measures used in the construction of a high-rise building built in the zone of mutual influence with old buildings. For this, the others solved the following tasks: survey of a group of interesting buildings, analysis of engineering and geological data for the construction site, applied a modern method of computer modeling by the finite element method and the program plus 3D to calculate with high accuracy with width of the outer zone of compressible soil along the perimeter of each buildings. We propose to consider an interesting positive example of taking into account all factors of mutual influence. A group of 3 houses in the Russian Federation in the Tambov city on the Savitskaya Street 156-158. The results of the technical survey of the group of 3 buildings built in the zone of mutual influence in the central part of Tambov are given. On the basis of the available engineering and geological data and the calculations of the stress strain state of the piece using the Plaxis 3D program complex, the causes of wall deformations were established. An analysis of the implemented measures to reduce mutual influence during the design of the attached high-rise building of the 3rd stage was made. These buildings are located in zone of mutual influence because their walls are tightly adjacent to each other. The first building was built in 1958 at Street Savitskaya 156. The second building was added after 5 years outside the zone of mutual influence because it is located 12 meters from the first. According to residents, it began to deform immediately after construction, and characteristic subsidence cracks began to appear on the facades, especially the southern section of the house bounded by second exception joint. In 1994, between 2 previously constructed buildings, construction began on the 3rd one, designed by Tambov Garajan project, with a height of 7 floors. It was a challenging engineering task because the new house fell into the zone of mutual influence of both buildings, which moreover had already damaged the load-bearing walls. To solve this problem, the following decisions were made. It was decided to strengthen the building of the first stage of construction from the side of the attached house with T-pills to separate the levels of bearing mutually influencing soils of the foundation. The foundation of the new building is deeply laid, pile 10 meters deep, with a pile diameter of 800 mm, with broadening in the lower part up to 1200 mm in order to exclude dynamic impacts. Drilling bills with broadening are accepted. The strip foundations of the building of the second stage were built of concrete blocks laid on a sand preparations with a thickness of 20 centimeters. Let's consider the influence of an extension of a new higher 7-story building of the existing 5-story one. In 2004 and 2018, the building of the first stage was recorded for the facades at the time of the survey in 2005, according to the residents as well as a result of a visual inspection. The condition of the building was established. House number 158, new cracks opening is not observed. The facades have only old, non-progressive cracks. The 7-story extension between house number 158 and 156 is currently cracked and evicted. Work is underway to strengthen two load-bearing structures. House number 156, there is the formation of new cracks and the opening of old ones. Destruction of the plastered layer, sacking on the walls. Engineering and geological situation in the construction area. All buildings of the group under construction have damage in the form of cracks on their facades. However, this damage are not related to mineral influence. So buildings of construction stages 1 and 2 have deformations associated with uneven subsidence. According to the scheme of engineering geological zoning of the territory of the Tambov city, the group of buildings under construction is located on the second above floodplain terrace of the Tisna River. Methods: 3D modeling of the stress state of the foundation building system was carried out in the calculation program Blocks 3D as a result of calculation pictures of the distribution of displacement and stress fields in base soil were obtained. The widest zone of soil subjected to vertical displacements 1636 mm is located along the perimeter of the building of the first stage of construction. Modeling in Blocks 3D showed that its width is about 8 meters along the perimeter of the building of the first stage, 1.2 meters along the perimeter of the building of the second stage, and 0.5 meters of the third stage of construction. Figure 6b illustrates the transfer total vertical stresses from the pile foundation of the building of the third stage of construction to the lower, more durable number 2 and 3 sandy soil. This reduces the vertical displacement under it. Accordingly, the influence from a higher building on neighboring less heavy ones has been reduced. Compressive vertical stress, as it were, extend over the boundaries of the soil layers, almost not connecting with each other. The pile foundation divided the zone of compressible soil beneath adjacent building to different depth, and he transferred the horizontal load from the heavy 7-story building to a greater depth. The scheme of engineering geological zoning shows the effectiveness of the considered engineering solution in condition of high variability of the deformative characteristic of base soils. Surveys showed the damage of buildings of the first and second stage was caused by uneven subsidence of the foundations, and the buildings of third stage were caused by a dissing error associated with the choice of an insufficient section of the columns. No deformations of the bearing walls caused by metal influence were found. Considering the surface life on the attached building is 22 years, complex engineering and geological condition of construction, considerable age of buildings located in the zone of influence. In general, this project can be considered very successful, and the engineering solution for the use of bored bill foundations in attached high-rise buildings is recommended to be used in such situations. Thanks for your attention.